Good day everyone. Today I'm going to discuss about on how to solve Warshall algorithm. Before we start, let us know first what is Warshall algorithm and also the important terms. What is Warshall algorithm? Warshall algorithm it is used for computing the transitive closure of a directed graph. When we see directed graph have edges with direction, while undirected graph have edges that do not have a direction. There are two methods on how to solve the Warshall algorithm, the adjacency matrix and Boolean sum. In adjacency matrix, it is also known as the connection matrix. It is a matrix with rows and columns labeled by graph vertices, with E1 if the G has a directed path and 0 if otherwise, in position according to whether and are adjacent or not. For a simple graph with no self-loops, the adjacency matrix must have zeros on the diagonal. When we see self-loops, it is an edge of graph which starts and ends at the same vertex. So this is the form of an adjacency matrix. For the Boolean sum, it is the second method to use on how to solve the Warshall algorithm by using row by column. There are two rules in Boolean sum. In rule number 1, if an element in row which is I and column which is J is 1 in R key minus 1, it remains 1 in R key. In rule number 2, if an element in row which is I and column which is J is 0 in R key minus 1, it has to be changed to 1 in R key if and only if the element in its row which is I and column which is key and the element in its column G and row key are both 1s in R key minus 1. So this is the form. So now I have here an example to use these two methods. As you can see in diagram, there are 5 vertices. V sub 1 is directed path to V sub 2. V sub 1 is directed path to V sub 3. V sub 1 is directed path to V sub 4. So V sub 2 is directed path to V sub 1. V sub 2 is directed path to V sub 5. V sub 3 is directed path to V sub 5. V sub 4 is directed path to V sub 2. And the last, V sub 5 is directed path to V sub 4. These are the vertices having a directed path. So class, is there a possible that vertices can directed path to itself? Or how about these vertices in V sub 2 can directed path to V sub 4? Yes, by listing the vertices having a new path. So these are the vertices having a new path. V sub 1 is directed path to V sub 1. V sub 1 is directed path to V sub 5. V sub 2 is directed path to V sub 2. V sub 2 is directed path to V sub 3. V sub 2 is directed path to V sub 4. V sub 3 is directed path to V sub 1. V sub 3 is directed path to V sub 2. And V sub 3 is directed path to itself. V sub 3 is directed path to V sub 4. V sub 4 is directed path to V sub 1. V sub 4 is directed path to V sub 3. V sub 4 is directed path to V sub 4. V sub 4 is directed path to V sub 5. V sub 5 is directed path to V sub 1. V sub 5 is directed path to V sub 2. V sub 5 is directed path to V sub 3. And the last, V sub 5 is directed path 5 to itself. So this is the adjacency matrix to get the transitive closure. So now, Let's proceed the next method, which is Boolean sum. So again, we will use the two rules of Boolean sum. In r to the power of 0 equals 1 is reflect the existence of path with no intermediate vertices, and r to the power of 0 is just the adjacency matrix. So highlighting the row and column are used for getting R1. In R1, 1 is reflect the existence of paths with intermediate vertices number in the row of V sub 2, which are V sub 2 to V sub 2, V sub 2 to V sub 3, and V sub 2 to V sub 4. Again, highlight row and column are used for getting R2. In R2, 1 is reflect the existence of paths with intermediate vertices from the row of V sub 1 and V sub 4. In V sub 1, there are two new paths which are V sub 1 to V sub 1 and V sub 1 to V sub 5. In V sub 4, there are also four new paths which are V sub 1 to V sub 4, V sub 3 to V sub 4, V sub 4 to V sub 4, and the last V sub 4 to V sub 5. Again, highlight the third row and third column to get the R3. In R3 is the same of the R2 of matrix because there is no vertex at all. In R4, there are four vertices in row V sub 5, which are V sub 1 to V sub 5, V sub 2 to V sub 5, V sub 3 to V sub 5, and the last V sub 5 to V sub 5. Getting the R5, highlight the row of V sub 5 and the column of V sub 5. In R5, a new path from vertex in row V sub 3, which are V sub 3 to V sub 1, V sub 3 to V sub 2, V sub 3 to V sub 3, and the last V sub 3 to V sub 4. So the matrix of R5 is called transitive closure. When we say transitive closure, the vertices can reach or connect to other vertices or by itself.